Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Engineering. So in this session, I am going to explain about the stress strain diagram and factors affecting the elasticity. So this stress strain diagram explains the elastic behavior of the material. So whenever whatever the stress we are giving, how the change is produced, that is called a strain. And the factors, so what are all the factors will affect the elasticity. So here the stress strain diagram. So for this we are considering the wire, that is one end of the wire is fixed and another end we are loading the weight gradually. So now we can plot the graph as the strain along the x-axis and the stress along the y-axis. So here if we are increasing the weight, means first we'll get a region OA. So this is a straight line. So in this region it obeys the Hooke's law. So Hooke's law is nothing but stress is directly proportional to strain. So this will obey here. And if we increase the load, means so that will reach the point B. So that is called the elastic limit. So this is the limit in which the elastic behavior exhibit. So further if we increase the load, means that will reach the point C, and this is called there will be a partially elastic and partially plastic. And further if we increase the load, means that will reach the point D, that is plastic range. So here only that will exhibit the plastic behavior, and after that that will reach the point E, that is the breaking point. So for if we increase the load continuously, means that will reach the breaking point. So before that that will thin down, that is the cross section will be minimized. So this is like finally that breaks down. So next one is the factors affecting the elasticity. So the effect of stress, effect of annealing, change in temperature, presence of impurity and nature of the crystal. The first one is effect of stress. So constant stress loses elastic property even within the elastic limit. So and loaded repeatedly are subjected to large number of cycle of stress, that is tired or ruptured. So elastic fatigue. So the loss of strength of the material caused by the repeated stress on it. So effect of temperature. The elasticity decreases with increase of temperature. Example, carbon. So lead at room temperature behave like a plastic, at low temperature that behave like a elastic material. So inward to make the pendulums. So creep resistance, the property of the material which can withstand its elastic property without fracture at high temperature. So the effect of impurities. The elastic properties may increase or decrease due to addition of impurities. So example, carbon in molten iron, potassium in gold increases the elastic property. The addition of impurity distorts lattice structures, that is decrease elastic property. Annealing the process and then the crystal structures. So annealing is nothing but heating to high temperature and then cool slowly, that is called annealing. So the effect of heat treatment and the metal processing. So annealing decreases the elastic property of the materials due to the formation of large crystal grains. Hammering and rolling, so that will increase the elastic property. The effect of crystal defects, that is nothing but based on the types, the single crystal and polycrystal. For single crystal the elastic behavior is more, for a polycrystal the comparatively the less, that is elastic behavior is less. And these are the factors that will affect the elastic modulus. So this we should know for the further application. So that's why we can use that material for a different applications. Thank you.